In this lecture, I'm going to show you how to manipulate the OSPF metric, which is the cost in the lab. We've got our usual lab setup of routers R1 to R5. All their interfaces are in networks beginning with 10. And if we have a look at the configuration, I'll do a show IP route on R1. You can see that I've already got OSPF configured on all of my routers. Back at the lab topology, the 10.1.2.0/24 network is available behind R4. So R1 could get there either along the top path via R2 and R3 or along the bottom path via R5. So let's have a look and see which path it is taking. So from our short IP route, I can see the route was learned via OSPF for the 10.1.2.0/24 network. It's going via 10.0.3.2, which is along the bottom path via R5, which is what we'd expect because it's a shorter path. And administrative distance is 110, the default for OSPF, and the metric, the cost currently is 3. So if you look back at the topology diagram again, the reason it's got a cost of 3 is that all the interfaces are fast Ethernet. So they all have a cost of 1. So we've got the link itself has got a cost of 1. Then the link from R4 to R5 is also a cost of 1. Then from R5 to R1 is also 1. So we add up 1, 1, and 1 together. That gives us our cost of 3. So we're using the default reference bandwidth of 100 there, where the best possible interface is a fast Ethernet interface. If we had gigabit Ethernet or 10 gigabit Ethernet, etc., that would still have a cost of 1. It would not be treated any better than the slower fast Ethernet interface. So we want to set a higher reference bandwidth so that those newer, faster Ethernet interfaces like gigabit and 10 gigabit Ethernet will be preferred over the slower fast Ethernet. So to do that, it's going to be the same config on all the routers. You want to configure this on all the routers in your network, or you can get unexpected results. You need them to all have the same consistent reference bandwidth. So I'm going to open up a text editor for this. And the commands I want to use are router OSPF1, and then the command is auto-cost reference-bandwidth, and I'll set it to a high enough value that I'm future-proofing myself as well. So I'll set this to 100,000, and then I'm going to copy and paste this into all of my routers. So there is, I need to do a config T. So there is R1, and you see it gives me the warning, make sure you do this on all of your routers. And I'll also paste it in to R2. And why did that not take the command? Let me try pasting it in again. Okay, that's got corrupted somehow. So let me go copy it again. So Control C to copy it from my text document again, and then back on the router, paste it in. That took it okay this time. That also shows you as well that even when you are copying and pasting on a Cisco router, have a look at the output and check it's taken the commands correctly. Do it also on R3, on R4, and R5. Okay, so that should be good now. So you saw when we did the old show IP route for the 10.1.2 network, the cost was 3. This should be updated now. So if I now do a do show IP route, you see for the 10.1.2 network, it's got a cost of 3,000 now, because 100,000 divided by 100 is 1,000, and we had the 3 links, so that gives us a total cost of 3,000. Okay, so that's the effect of the reference bandwidth. If we had another path which had gigabit Ethernet interfaces now, rather than each of those having a cost of 1,000, they would have a cost of 100, so it would be preferred. Okay, next thing to do is let's change the path here. So the traffic for 10.1.2 is currently going via 10.0.3.2, which is on R5 along the bottom path with a cost of 3,000. So have a look at our network topology again. And what I want to do is change the traffic. So rather than going along the bottom path, I'm going to move it to the top path. I could either give the top path a lower cost, or I can manipulating it by giving the bottom path a higher cost than what it is now. So there's only 2 links along the bottom, so it's going to be quicker to change it along the bottom path. So each link now currently has a cost of 1,000. Let's set these 2 links here from R1 to R5 and from R5 to R4 to have a cost of 2,000 instead. So that will give the bottom path a total cost of 5,000, the 2,000 here, the 2,000 from R5 to R4, and the 1,000 on the link itself. So 5,000 on the bottom path. Along the top path will be 1, 2, 3, 4,000. So the top path will be preferred. And I want to do this on all the interfaces along the bottom path so that I've got the consistent cost on each link, on both sides of the link. So I'll go on to R1 first. And that was on interface fast 3/0 is facing R5. And I'll say IP cost OSPF 2000. And it's because I've missed out the OSPF. So IP OSPF, sorry, cost 2000 is the correct command. So that was on R1. Then on R5, it's on interfaces fast 2/0 IP OSPF cost 2000. And I'll hit the up arrow a couple of times and change this to fast 3/0 and IP OSPF cost 2000. And finally on R4, it's interface fast 2/0, which is facing R5, and IP OSPF cost 2000. So that bottom path should now be a higher cost than the top path. If I go back onto R1, and I do a show IP route now, you see previously it was going via 10.0.3.2. Now to get to 10.1.2.0, the next hop is 10.0.0.2. That's R2 along the top path. Okay, so that's how we change the reference bandwidth and also how we can manipulate the paths our traffic is going to take through the OSPF cost. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.